Hi, I'm Hamza. We're the team building honeypots to track AI web scrapers. So scrapers are bots or users that parse through websites to extract data. And a big problem with scrapers is that it is really hard to control which bots can access your website due to spoofing, which is bots lying about their identity online. They do that by changing their ASN to either mimic other bots or mimic other users. For example, let's assume two bots visit your website and they're both claiming to be Googlebot. Uh, their user agent is saying Googlebot. One thing you can do is look up their IP address on the American Registry for Internet Numbers, which will provide more information about the owner of the IP address. And it turns out that bot 2 was actually not Google, but actually a different scraper imitating Google. So our goal with this project is to analyze scraper behavior and detect spoofing instances and collect ground truth data to improve our models that detect spoofing. So we will do that by performing some EDA to learn more about the data. Then we will build honeypots to collect ground truth data for our models. And then we will build machine learning models to detect spoofing instances. And then we will conclude our work by packaging everything in a CLI application. So our data set comes from Duke OIT website. It contains more than 9 million requests from scrapers. This is all excluding user data, and the data spans from February 22nd all the way to 9th of July. So let's start with the EDA.
Hi, I'm Adonius, and now we will be going into some of the EDA we did. So one of the tools that we used in our data analysis was an HDB scan, which is a density-based clustering algorithm. And so our goal with that was to do some EDA and more specifically identify some patterns in the bot behavior. And while we were investigating the clusters, we found a user agent that actually had a misspelling of the Mozilla token, pronounced actually more like Mozilla. And so this actually suggests that this user agent was manually entered. And we did some like external research into like who this user agent could actually be. And we found that it actually belongs to a malicious bot. And a cybersecurity expert named Daniel Seed actually had this user agent hack several of his sites, and he found over 150,000 attack attempts on several of his sites in the span of like 30 days, about a month. And so it actually is claiming to be a Samsung Galaxy S8 Active running on Android 7 and Chrome version 60, all of which are super outdated. And so we use this to help us enrich our classification models and our time series analysis models. And now we will be going into the honeypots.
Hello guys, I'm James and I'll be talking about the honeypots. So the goal is to collect ground truth data on spoofing by creating these websites with a bunch of different hidden pages so that we can log a bunch of important metadata such as the IP address, the ASN, and the user agent. And to determine whether or not a bot is spoofing, we do a matching algorithm, in which case we begin by matching the patterns against a well-known JSON file with around 600 different bots to see if the bot even exists. And then we can go into some verification methods if it does exist. And to start, we do a CIDR check, which basically just looks at the network part of the IP address, checking whether or not belongs to the legitimate network it says it's coming from. And we also do a reverse DNS check to be able to determine whether or not the IP actually belongs to the domain the bot is saying it comes from. And then next, if there are no verification methods, we can then do a user agent check. In this case, it is a Jacquard mathematical discrete algorithm, in which case we do a intersection over the union to be able to get a ratio of whether or not the bot should actually be a spoof or not and compare it against a given threshold. And we have a bunch of different weights for each different product, each token of the user agent that we have. And then after that, we are able to actually fully determine whether or not it's spoofing, not spoofing, or if it's just an unverifiable bot. And determine to host everything, we use Oracle Cloud, Nginx, Flask, and Gunicorn, and log everything to Supabase.
So here comes to our classification part. We build our classification model on the dataset provided by Duke OIT. And before going to our model, we do some time series processing. For example, if multiple requests are made from one IP, we'll group it into one session. And here are some key metrics derived from the time series dataset. You could see it performs really differently from the spoofer to the legal counterparts. And finally, we get pretty good results. We achieve 96% recall rate with our XGBoost models and precision rate about 100%.
Hey guys, I'm Eva, and I'm going to be talking about the conclusion. So far you've seen us talk about how we conducted some EDA to find spoofed user agents manually. We made some honeypots to collect ground truth data, which we could then feed into our classifier to increase performance. And now we're combining all of this into one command line or CLI application. And how that works is that it takes a request input and it feeds it into the feature engineering pipeline, which then feeds it into a cluster prediction model that we have, which is our pre-trained HDB scan model, and also our classification model, which is our pre-trained XGBoost model. This outputs an access type, which is what group does this behave most similarly to, like either an iPhone user or maybe a Google bot spoofer or something else. And we also combine two spoofing scores from our clustering and our classification into one final spoofing score, which tells us how likely this new request is to be spoofed. So for next steps, we just want to continue refining our model's performance because right now it's a little slow and we want this to have real-time detection applications. And we would like to thank Dr. Emily Wenger with our project, and Gregory Hirschlag, who's the leader of our program, Data Plus, Daniel Seed, who was extremely helpful in researching spoofed user agents like Mozilla, and the GitHub repository ArcJet for our honeypots. And yeah, that was our project.